It comes on, it's got a safety switch inside of it. When it comes on, it creates vacuum, it turns the safety switch on, and lets the computer know that, hey, my flue fan is working, my updraft fan is working. So once it works, it stays on for a while, then the call for heat, the gas valve will open, allow the gas to go into the system, and it's either electronically fired, which this is electronically fired, kind of like a glow plug or a spark initiator will actually ignite the gas. And once the gas is lit, it blows the gas into the exchangers. Now the heat exchangers are probably the most important part to the fire investigator, because this is exactly probably what causes the most problems. This is your heat exchanger. So the gas is now forced up as it's basically combusted. The combusted gas is forced up into these heat exchangers. And so now we have the gas, as it's ignited, inside these heat exchangers here, basically burning and heating this metal. Now once it reaches a certain temperature, there's another little device inside that said, okay, I've got the desired temperature, it turns the fan on. So the fan blows the air through the heat exchangers. You can see there's room allowed for the air to come through these heat exchangers, and as that air goes across these superheated metal, because remember, the combusted gases are in fire inside the exchanger. Through conduction, it picks up that heat. And as it blows across these heat exchangers, what comes out is now heated air. So it's very, very simple physics, and it's all through conduction. However, the problem with it is, what we have to understand is, over a period of time, this metal, it flexes, right? When you heat metal, it expands. When you cool metal, it contracts. And then the coil sits on top of this, and sometimes the coil will leak and it gets water in it, so you have some rusting. So now we have flexion, we have some oxidation, some rust. These exchangers will crack, or they'll rust out. So now that allows the gas to escape into the airflow, where the air comes out. Now, two things can happen. You can have an abundance of gas buildup inside the air handler itself, and then you can have a problem in that respect when it comes on. But what really happens is, when the fan comes on, it forces air through those cracks into the exchanger and pushes the fire out back through here. Because this is where the gas goes in, right? I mean, you can't have combustion without oxygen, right? So this is kind of where the gas goes in, it pulls the oxygen in. This is the orifice right up under my finger. Each one of these is that orifice valve, and it's controlled, but right there is the fuel-air mixture. And so as it's going into this system, the fuel-air mixture is right, and now it just combusts inside the chamber. And once it's burning inside the chamber, it's no problem. However, when the chamber becomes damaged through oxidation or through just a period of time of expanding and contracting, now when the fan blows on it, which is down here under this control board, the fan blows up through, around the exchangers, into those cracks and pushes that gas back out. And that's when we have problems. That's when these furnaces called catch on fire.